Hello everyone, so let's go over primary, secondary, and tertiary alkyl halides. So before we begin, what is an alkyl halide? So an alkyl halide is when you have a halogen that replaces a hydrogen inside of an alkane. So in other words, you have an alkane and one of those hydrogens is replaced by a halogen. And what is a halogen? A halogen, typically what you'll see in organic chemistry is fluorine, chlorine, bromine, and iodine. And again, they are listed on the periodic table. They are right next to the noble gases. So I'm going to use a Z to represent alkyl halide. And know that that Z could be a bromine, it could be a chlorine, it could be a fluorine, it could be an iodine, but I'm just going to represent it as Z. So how do we know what would be a primary alkyl halide, a secondary alkyl halide, or tertiary alkyl halide? So I'm going to use that yellow carbon to show you, like, that's my like the carbon that I'm focusing on, okay? And then the purple carbon is how many are the attachments of that yellow carbon. So for example, that one yellow carbon is attached to one purple carbon. So since it's only attached to another purple carbon, to one purple carbon, that makes the yellow carbon a primary carbon. And since the Z is attached to that primary carbon, it is a primary alkyl halide. And again, since the blue hydrogen is attached to that carbon, that yellow carbon is a primary hydrogen. Okay. So in the next example, you can see you have a yellow carbon attached to two purple carbons. So that yellow carbon is a secondary carbon. And the Z is attached to that yellow carbon, which makes it a secondary alkyl halide. And then the last one, you can see a yellow carbon attached to three purple carbons. But notice that there's no hydrogen. And again, the reasoning is you're already attached to that alkyl halide. So the alkyl halide is going to be a tertiary alkyl halide. So let me say that one more time. The yellow carbon is attached to three purple carbons. So that makes that yellow carbon a tertiary carbon. The Z is attached to that tertiary carbon, which makes that Z a tertiary alkyl halide. But the point that I wanted to make earlier is that there's going to be no hydrogen. And for those of you that didn't see my last video, the reason that you don't see any hydrogens in this case is because, again, carbon can only have 4 bonds. And so if you look in the first example, with the yellow carbon is attached to a Z, a purple carbon, and 2 hydrogens, 4 bonds. The second example, the yellow carbon is attached to 2 purple carbons, a hydrogen, and a Z, 4 bonds. And the last one, the yellow carbon is attached to 3 purple carbons and a Z, 4 bonds. So there's nowhere for the hydrogen to attach. That's why when you deal with alkyl halides, you're not going to have any tertiary hydrogens or quaternary carbons for that matter. That's just not going to happen. And again, carbon can only have 4 bonds. So again, when you see the other video, go check that out. But you can have quaternary carbons. But again, you're not going to have that when you have an alkyl halide. You're capped at a tertiary carbon. And it should make sense, right? Because carbon can only have 4 bonds. So if you have an alkyl halide and a tertiary carbon, again, you have your 4 bonds right there. That's why you can't have 4 carbons and an alkyl halide. That's the reasoning, because again, carbon can only have 4 bonds. So if you enjoyed this video, again, it takes time to create this content, so please follow, like, share, and thanks again for watching.